Hello class, this is a video tutorial on the Z-score or the Z-score depending on where you're from. The Z-score or standardized score measures raw scores as a distance from the mean. The unit of measurement used is standard deviations, and the Z-score can either be positive if the raw score is greater than the mean, or negative if the raw score is less than the mean. So let's do a simple analysis of this. So let's take a look. So we have a normal distribution where the mean is 20 and the standard deviation is 8. We've seen in previous videos if we add one standard deviation, so this is plus one standard deviation because we added 20 plus 8, so that's 28. If we take away 8 from 20, so that's minus 1 standard deviation. If we add 2 standard deviations, so 20 plus 16 is 36. So 36 is a standard deviation of 2. You can probably guess that this is a standard deviation of 3. This is a standard deviation of negative 2. And we actually can't get negative numbers here. But, let's just write it down. A standard deviation of minus 3 is a score of negative 4. Okay, but that can't exist in this data set, so let's just ignore it for now. So as you can see, these are the standard deviations from the mean. So 28 is plus 1 standard deviation from the mean, which means 28, its Z-score, is equal to plus 1. 12 is 1 standard deviation away from the mean, which means it has a Z-score of, so 12 has a Z-score of negative 1. Okay, now this is all well and good, and I hope that kind of gave you an insight to this. But what happens if we want a Z-score of, let's say, this one here? Let's say we had 24, a score of 24. What is that Z-score? All right, so this is what we're going to aim to find out in this video here. So let's move right along. To calculate the Z-score of any value from a normally distributed data set, we use this formula. Z equals x minus x bar over sigma x. I know that's a lot of jargon here, but let's just take a look at what each of these mean. So the Z-score, well, that's just the number we're looking for. Capital X is the value that we are calculating. X bar is the mean, and sigma x is the standard deviation of that data set. Please take note that sometimes you may see the standard deviation as Sx. So make sure you memorize this formula because it's the one we're going to be using now. So from a normal distribution with a mean of 62, so let's write this down so we can summarize it. So x bar is 62 and a standard deviation of 8. So S of x, or you can use sigma x, whichever you like, is 8. Let's find the Z-scores of these numbers here. So let's actually copy down this formula because we're going to be using it. Let's paste this in. There we are. So we want to calculate the Z-score, and we've been given the mean and the standard deviation. So let's write this down. So Z is equal to minus 62 over sigma x, or the standard deviation, which is 8. Capital X is the number that we are calculating. So in this case, it's going to be 68. So 68. Using our calculator for this, let's calculate this. 68 minus 62 divided by 8. This gives us a Z-score of 0.75. Okay. Let's do a z-score of, oh sorry, let's calculate the z-score of 54. Very straightforward. So z, or z, whichever you want to use it, is going to be, well, the score that we are calculating, 54. We're subtracting the mean of this data set. The mean is 62. Divided by sigma x, or the standard deviation, in which case it's going to be 8. All over 8. Calculating this, 54 minus 62 over 8. This is a z-score of exactly -1. Let's calculate this again. 74, z equals 74, take away the mean of 62 over the standard deviation of 8. So 74 minus 62 over 8. Going to be 1.5. Let's do this last one. Let's find the z-score of a result of 40. So z equals 40 take away 62 over 8. 40 take away 62 over 8. That's negative 2.75. Now, that's calculating the z-score, and I hope that gave you an understanding of how to calculate it, but let's delve some more into this, and let's plot these numbers onto a normal distribution. So, here we go. Let's draw a normal distribution here. There we are. So for this data set, the mean is 62. So that is going to be 62. And if we were now to plot these points onto our normal distribution, 68 is 0.75, so it's positive. So it should be very close to it. That's 0.75 as a z-score, and that is equivalent to 68. A z-score of -1 we've seen from the previous videos, so -1 would be here, and then that score would be corresponding to 54. A z-score of 1.5 would be approximately, let's say here, that's a z-score of 1.5, and that is a data score of 74. Lastly, if we have a z-score of -2.75, -2.75 is very close to the end. It's -2.75. That's equal to a z-score of, not a z-score, a raw mark, or a data mark of 40. So I hope that gave you an insight as to what z-scores are and how to calculate them. Hope to see you in the next video. Best of luck.